Hello, thank you for joining us today. My name is Cameron, and today we'll be going over VSCO product. This is Atago's viscosity meter. So you may have caught a couple of our past meetups. So these were highlighting our different refractometers, pH meters, different types of meters, oftentimes handhelds. Today's going to be a little bit different. We're going to be looking at our viscosity meter. So it's going to check the viscousness of your sample. So I will be doing a pretty general overview, what viscosity is, what goes into it, but there are actually a lot of different applications, so we did want to highlight some of those for you today. This is just something that's starting to get used in quality control over many different industries. So we will talk a little bit more about what exactly you're looking for with viscosity, but some of these industries you can look at hygiene products, something like desserts, syrups. You can look at even engine oil, ice cream. There's just a whole bunch of different applications, probably looking at over 20 plus applications with just this one instrument. So really a lot of versatility to do that type of quality control. So today we're going to be doing kind of a general overview, but we will be looking close up at our VSCO B unit here. So you can see we have a couple different things out here. So this is our VSCO B, more of kind of like a mounted instrument type. But we do have, I do want to highlight this option here. Hopefully that's in the field of view here, but really gets quite compact and portable. This is a great trait of this instrument, is its portability. So with our standard VSCO, you can just carry this around quite easily, and we actually get even smaller than this with our VSCO model, getting down to 895 grams. So really want to highlight that, just super portable. But yeah, so there are a couple different types that we have. We have the standard VSCO, VSCO 895, VSCO B, and we have a couple different packages, so this will kind of cater to your needs, whether or not you're looking for something like a paper cup adapter, which is basically if you're looking at something like honey or something that's very thick and not super easy to clean on a constant basis. We can use those paper cups, just get rid of them, put in the next sample. So there's that. We have a couple different other packages that will involve a temperature controller, these types of things. So just depending on what your needs are, we will be able to supply that to you. I did want to kind of just look at a general overview of what viscosity is. So we will be shifting to our slides here, just to make sure we're kind of all on the same page here. So we'll quickly shift. So as I was saying briefly before, viscosity is essentially quantifying the viscousness of a sample, or in other words, it's just how thick or resistant to motion a particular sample is. So something that you could think of is, in terms of scale, is you're looking at water, which is measured as 1 MPa. So we do have centipoise or millipascals, so that would be 1 all the way up to something like honey, which is going to be around 1,300 times more viscous than water. So just much more resistant to motion. So our instruments are basically quantifying that difference, and we can do that in a few different ways. So one note that we can probably see here on B5 is you do want to really keep in mind how temperature is going to affect the viscosity of your sample. So this is much like with bricks. There's a refractive index, to be more specific, but there's a direct correlation. As the temperature rises, it's going to make the sample less viscous. So we do have ways of monitoring that. I'm not sure if it's currently visible. We'll definitely get a close-up in just a little bit, but we do have a little thermometer here which is going to actively represent the temperature, and you will have the ability to plug in a temperature controller if you're looking for that. We have a water jacket as well that can surround the beaker that you're using. Things like this are definitely worth considering depending on your application. So we can see on the bottom there again, water, cooking oil, go up to honey, and then mayonnaise is actually way out there, all the way at 8,000 millipascals. And then again, just how this kind of factors into things, or the importance of it. So salt, sugar, these types of things, that's pretty self-explanatory, you know, what we're measuring and how it kind of manifests into the end product. But with viscosity, you can kind of see, so is something that's a little more subjective, maybe, we'll actually be able to measure with this. So is it smooth, is it crunchy, kind of silky? So these are actually very important qualities depending on the industry. So if you think of something like noodles, you know, am I going to have a harder texture when I'm giving it to the ultimate consumer, or am I going to look for something that's a little fluffier? So this unit will be able to highlight that for you. You know, so beer, cream, detergent, these types of things, we'll still take these considerations in. I did want to quickly highlight Newtonian versus non-Newtonian. So this is really just kind of a fancy way of saying, if we apply force to a particular sample, how will that change the nature of it? So we have a good example is honey and butter here, as we can see. So if I'm spreading it, it's going to require the same amount of force in one way, but if I'm mixing, we're going to have a little bit more force required with the butter. So the reason that this is important to consider is whether or not your sample is going to change its viscosity with applied force over time, meaning you're going to get different results. So we have a rotational viscometer here, and what we need to consider is, if I'm having the unit kind of apply that force in it's actually a very subtle way, but if we're applying force over a long period of time, how will this change or not change is basically what we're looking at with Newtonian versus non-Newtonian. So some examples of Newtonian are, you know, just think of things that kind of just slide regardless. So we have honey or water, whatnot. So just something to consider depending on your sample. Go on here to a couple of our different types I wanted to just highlight. I was briefly talking about the rotational viscosity meter that we have. You know, this has really developed over time. So traditionally, viscosity meters have actually been around for quite a while, but these were the more traditional B-type viscometer styles. So we've actually developed what our VSCO is, has come quite a long way in terms of, you know, I mentioned the portability, but just the speed, the range, the accuracy, all of these things have come a really long way, and that's why we think our rotational viscometer is just, you know, exactly what you should be looking for, regardless of your application type, really. But we do have, you know, the capillary falling ball vibrating, so these do slightly different things to attain those measurements. But we are able to get both millipascals and centipoise with our rotational viscometer, and in a very efficient way, we feel. So please feel free to review those differences on your own time if you're interested. So I'd like to briefly go over our standard VSCO, which we can actually see here in the box. So these two units in front of you are quite similar. So the advantage of this one is, again, portability. You are going to also have the compatibility with our package A for the paper cup adapter. This one here is more of a mounted type, and we'll get into why that's a good thing, but just a quick highlight. So you'll notice here I can actually move this up and down, so for the easy height adjustment, which is actually kind of really comes into play in a couple different circumstances. So this one's going to sacrifice a little portability, but give you tons of flexibility and efficiency in the right environment. So just a brief highlight, we can see we actually have the same range here, which is going to be from 50 millipascals to up to 2 million, depending on, you might have noticed we have 4 different spindles out here and 1 being used. So depending on the spindle that you're using, you're going to have a slightly different range, but the unit itself will cover all the way up to that with just the standard VSCO here. And we do have plus or minus 1% of the maximum viscosity accuracy with this one as well. So it is a slightly different setup, but you're getting largely the same functionality. Moving along here. So I did want to also highlight, you can probably see here we have a 500 milliliter beaker with sample filled up. You are going to have to take into consideration the involvement of the spindle, and we do have a little stirrup thermometer in there, so that's going to change it slightly. But you are looking at about that size sample volume, and this is the same that you'll see with traditional B-type viscometers. But with other units like our VSCO and VSCO 895, we can actually get that sample size down to 100 milliliters or even as low as 15, which is just tremendous. So you won't be losing much sample. It's really going to pay off over time, we feel. So that's an important consideration. We do have it plugged in today, but we can operate fully off of batteries alone. Another great feature of all of these VSCO units here. And we probably won't get into it today, but there is a digital level adjustment, which is actually a really neat feature. I'm not sure if we can see here, but this will actually tell you how level the viscometer is. So I have actually been in situations where I feel like I'm on a very flat surface, but this will tell you exactly how to adjust, and we have little screws here that you can manually adjust to get that just right, and then your sample will be measured accurately in that way. So really nice feature of these. We're going to just have a little section in here to adjust. You can in the moment change it, and you'll make sure that things are level and you'll get the readings you're looking for. So we've talked a bit about how lightweight it is. We can get all the way down to 895 grams. So again, going back to the Newtonian versus non-Newtonian, sometimes we do have sustained measurements. So what's a neat feature about this is we have an auto stop function, so we can basically set it for a certain amount of time, and it will start, it will stop when we indicate. So another cool feature, we actually have several user scales. So if you're looking at a couple different samples, different ranges, different spindles, whatever, we can actually input that, save it, and switch to a different scale later, which is really neat as well. Moving forward here, I did want to just quickly go over the package types. So again, we don't have anything visually represented today, but we do have package A, which is available if you're looking for basically to throw away your sample and get another one in right away. So this is going to be our paper cup adapter with the package A. We do have package B, which is going to include our ultra low adapter, the ULA, so that's going to enable measurements all the way down to 1 to 2,000 millipascals. So if you're really concerned with that lower range, we do have that package available. I've seen that actually used with this VSCO B, using those in tandem. We have package C, which is going to combine the two, and then there's package D, which is an important highlight because this is a very nice way to consistently get the same temperature and in turn create the same or create accurate readings for you by monitoring that temperature. So we can just plug in and regulate that temperature. So a few different packages and a couple different units. So again, we really feel like this will cover many different applications between those things. Just flipping to the temperature controller, we can see it's actually going to cover between 5 to 90 degrees Celsius. So big range there. You do want to usually look to take your measurements, regardless of which VSCO you're using. You're going to probably want to be in a range of 10 to 40 degrees Celsius, but with that temperature control, we can actually get quite a range there. And just moving forward here. So I did want to just kind of get into VSCO B a little bit, and then we'll do a quick measurement. So looking at the specs here, we do have four different spindles available, so those are going to give you slightly different ranges. You do have some overlap, so it's important to keep in mind that I'll hold this up here, but we do have a little guide, and that's going to indicate what RPM with what spindle is going to create a particular millipascal range or CP range for you. So this is kind of what we would call a loose guide. You will have some overlap between the different spindles, but it is probably important to keep in mind that you can get less repeatability, so it's good to use sort of a trial and error approach once you have that baseline. Good to keep in mind. So again, this does have just really high accuracy levels. You're just looking at plus or minus 1% of the maximum viscosity, and quite a range in terms of speed available to you, seen there. 0.01 to 250 RPM. And so we will jump into a quick measurement. You've probably noticed from past meetups that we usually zero set the instrument. We highlight you know, how things are reference set and whatnot. We don't really recommend calibrating, so to speak, before using this instrument, but we do recommend that if there are drastic changes in the environment, or if you're looking to kind of verify the consistency of your results, that you do calibrate this instrument. So we can actually provide quite a range of standard solution here at Otago. So that's going to go all the way from 20 to up to 2,000 for our standard liquids here. So be sure to check that out, have that on hand. So let's quickly jump in, just show you guys how this unit kind of looks here. We will be looking at a dish soap sample today. Hopefully that is visible there. And we can see we have it set up to 500 milliliters there, kind of pre-set up. We do also have a stirrup. I wanted to just highlight that there. The stirrup on this section is visible, I hope, and then we have a little temperature sensor that's in there as well. So the stirrup is going to, when you don't have maximum visibility, this is a pretty translucent sample, but when you don't have visibility, this is going to give you kind of a guideline so you're not hitting the bottom of the beaker with the spindle. and in addition to that, it's going to actually reduce the amount of air bubbles, which can affect your viscosity level. Also keeping that in mind, it's good to kind of let a product or sample settle before you take your measurements if you are getting, if it is a bubbly sample. So I do want to power the unit on here. So we're right into it. As I was speaking about before, we do have that level function right there. And you have your scales, the auto stop. So I'm really just clicking one button here, very accessible. And we hopefully can see, I do have it set to 20 RPMs. This is going to be at 20 degrees Celsius. And since I am using the L1 spindle, remember these do have slightly different ranges, that's going to provide a maximum viscosity reading of 300 centipoise or 290, just taking a little bit off there. So if I hit start here, we can actually see that the spindle is moving a little bit, creating that rotation. So this is in the lower range of RPM, so we're not going to be generating a ton of activity here, but do see it in action there. And hopefully we can zoom in here and just see we're at currently 138.9 to 139.0 centipoise, and directly beneath that we're at 47.9% torque. And this is a good indicator because, again, going back to that guide there, you will see some overlap between the spindles, but we just generally want to stay within a range of 10 to 100% torque. If you are in that safe range, you'll be getting the repeatability that you're looking for. So everything's looking good so far. We're sitting right around 139 centipoise for this sample. Now I did want to, again, just reiterate, go ahead and shut this off. And what's really neat, even if I don't have a user scale made before the fact, I can actually, it's going to just automatically save all of my settings. So I'm going to have my RPM, I'm going to have you know, the max CP, everything there is going to be represented next time I power the unit on. It's very handy. So we're going to go ahead and just hold the power button and it will resume as we like. So I did want to just quickly re-highlight one of the advantages of this VSCO B unit, and that is in its easy height adjustment. So all I have to do here is just pinch these and go up and down as needed. So this is going to, as you can tell, probably make the cleanup, inserting different sample process, all of that stuff just much easier than you'd see from other types of viscometers. So that about covers it. So I did want to leave the last couple minutes in case there were any questions here. We do have a couple different products available, so I would understand if there are. Before that though, we do have on the 31st, a week from today, I believe it's going to be at 10:30 a.m. here Pacific Standard Time. We do have another meetup, and this is going to be on the PAL 10S. So we'll be looking at the importance of testing urine for anyone that's in that industry. That will be 1 week from today, so please join us for that. So if we have any questions, I think we might be okay. All right. Well, thank you for joining our overview of VSCO B and VSCO today. We will maybe be going into this later on in more detail, but please reach out if you have any questions. Thank you so much.